This is ACT skill number 34. Please do second plus 712. Now here's the deal. When you get to your calculator, please hit the word mode, everyone. Your calculator, when it's been reset, will always be in terms of radians. So when you're working with trig problems, you need to look to see, are we working with radians here or are we working with degrees? And I'll show you when you get a little further how you can tell. So, SOHCAHTOA, that's the one thing I know that you have learned. SOHCAHTOA, you've learned that with your geometry teacher. So let's just write down what we know. We know the sine of an angle is equal to opposite over hypotenuse. Please write this down as well. We know the cosine of an angle is equal to the adjacent over the hypotenuse. And the tangent of an angle is equal to the opposite over the adjacent. So if you're always wondering, how do we get SOHCAHTOA? S-O-H, SOHCAHTOA. And the idea was for you to remember the order in which you do things for sine, cosine, and tangent. Okay, so for the right triangle to the right here, what is the tangent of z? So let's circle this angle here. We're looking at this angle. So we know tangent is TOA, opposite over adjacent. So opposite is 3. Adjacent is the leg that helps you form this angle, but it cannot consist of the hypotenuse. So 3 over 4. Well, 3 over 4 is not one of our options that we can see. We want to figure out an equivalent form. If you don't know what 3 over 4 is equivalent to, take 3 divided by 4. It's equal to 0.75. Flip to the back side. Standing on Turtle's back, Vince casts a 4-meter shadow as shown. The angle of the elevation from the tip of the shadow to the top of Vince's head is 40 degrees. To the nearest tenth of a meter, how high is the top of his head? We want to know this. They put a question mark here. So we want to decide right now, should I use sine, cosine, or tangent? So from this angle, if you had to describe this length or this side, you would say opposite. This is opposite side. And if you had to describe this given measurement, you would say this is adjacent to this angle. Opposite and adjacent. What trig function do we use that's opposite and adjacent? Tangent. So I'm going to do tangent of this angle. Please don't work ahead. Tangent of this angle is opposite, we don't know that measurement, over adjacent. So do you see how I'm given a degrees? You have to turn your calculator into degrees right now. Please hit mode, go down to degrees, go over the top of it, and press enter. Mode, degrees, press enter, and now press clear. So if you want to solve for x, we want to get rid of this 4. As a reminder, the 4 is being divided. Opposite of dividing is multiplying. Whatever you do to the left, we're going to do to the right. 4's cancel. Now I'm going to take 4 times the tangent of 40. I want you to be careful with this. Watch real quick, please. Eyes up here. If you type tangent of 40 times 4, your calculator may think, if you look up here, if you do tangent of 40 times 4, what would your calculator think? It would actually think I'm going to try to do tangent of 160, right? So we're going to do a 4 in front. So 4 times the tangent of 40. Press enter. Approximately 3.3, 3.4 rounded. Now look at your options. 3.4. Okay, you're going to turn to your partner, and you have 20 seconds to go over this with your partner to make sure you both understand. Go ahead. Okay, you're next up. So, let's draw a right triangle. And let's label it A, B, C. Now, how do I know how to label it? Just know that A can be either one of these angles, but I don't want A to be the right angle. If the sine of A is 3/5, so let's go back again. You're reviewing from geometry. Sine means opposite over hypotenuse. So this angle right here, A, what length represents the opposite? This one down here, right? So opposite is 3, so let's write a 3 here. And the hypotenuse then would be 5. Well, what would be the tangent? So remember, to do tangent, I need to know the tangent of this angle is going to be, tangent is going to be opposite over, not hypotenuse, but adjacent. So I know the opposite, but I don't know the adjacent. But I have a right triangle. So when you have a right triangle and you know 2 of the 3 sides, how do you figure out the missing side? Yeah, the Pythagorean theorem. A squared plus B squared equals C squared. So your A and your B are going to be the legs, the 2 sides that create the 90-degree angles. And your hypotenuse, the longest of the 3 sides, will be your C. So 3 squared plus B squared equals 5 squared. 9 plus B squared equals 25. When I subtract a 9 to the opposite side, I end up with 16. And now I solve to get, remember, a positive and a negative 4. But this describes lengths, and lengths are always positive, so positive 4 is that missing length. So I'm going to go up top to that triangle, and I'm going to put a 4 out front here. Now when I figure out the tangent of this angle, it's going to be opposite, which still remains as 3, over adjacent, which is 4. Now 3/4 is option G. Okay, comes to number 3. Have one person between the 2 of you please read it. Go ahead. So circle B, please. We want to know what is the sine of B. Remember, sine again is going to be opposite over hypotenuse. So what is directly opposite of this angle? It is the number 5. Now hypotenuse is always directly across from the 90-degree angle, or it's the longest of the 3 sides. So 5/7, correct answer is A. Number 4, for the right triangle shown, so let's do a little right angle here. For the right triangle shown, what is the cosine of Z? Okay, so cosine is going to be what, guys? Adjacent over hypotenuse. So adjacent to this angle is 4, and hypotenuse is 5. 4/5 is not present, and if you don't know what that is as a decimal, divide it to get 0.8.